Well, welcome to the last of the Max-Min videos. This is the second bonus video that we've got for you. And this one you won't find in the books. This one is just one that I've made up myself. And what we've got is that we want to find the max-min for, and the nature for f of x is x cubed minus 2x squared plus x minus 1. Again, it's a cubic. Now, because I like to cheat a lot, what I've done is that I've actually graphed that in Desmos, www.desmos.com, and I entered this. I entered y equals x cubed minus 2x squared plus x minus 1 into Desmos, and Desmos gave me this beautiful little curve here. And as you can see, there's a local maximum here and a local minimum here. Now we say local because if you just follow it down here, it actually goes lower than that. All right, and I say it's a local maximum because if you just go over here, it actually goes above that. So these are only maximum in these areas, and that's why we use local. Okay, so keep that in mind. That's one of the reasons that it's actually good just to do this one here. So let's just find these then and see what they come out to be. So x cubed minus 2x squared plus x minus 1. So it looks as though one of them is at 1, negative 1. That looks as though it's the minimum. And the maximum, the local maximum, looks as though it's what, about what would you say, 0.3 or something? And that looks about negative 0.75, 0.8, something like that. Well, let's find out. So you should be able to just talk everybody through this now. You know, you really shouldn't need me anymore. So at the turning points, the derivative is 0, as usual. The derivative turns out to be 3x squared minus 4x plus 1. I'll just take you back up there again. So if we differentiate that guy, it becomes 3x squared minus 4x plus 1. All right, so you can play the video back and you'll find these things really easily. All right, so 3x squared minus 4x plus 1. Let's go back down. So you need to find where that is 0 for the turning points. In other words, to find the root of that. Again, it's a quadratic equation. So what I've done is that I've just plugged it into the quadratic formula, and the roots, if you just plug the values in, so a is 3, b is negative 4, and c is 1, put those values in, and it turns out that the roots are 2/6, and I hope you all know that's a third, and 1. So the two roots are 1/3 and 1. These are turning points. It says check with the graph. We've already done that, so that looks about right. So that there, it's about a third. A third's about 0.33, 0.4, and that is exactly 1. So it looks as though we've gotten. So now we need to find the nature and the value, and then that's us. So the nature, we differentiate our function again. So there's your function, so you differentiate it. And these always turn out to be easier. When you differentiate it again, the function becomes easier. So if you differentiate that, it becomes 6x take away 4. And if you just put the 2 points in, x is a third. F double dash of a third is going to be 6 times a third minus 4, which is going to be negative 2. Now the whole point about it is that's less than 0, so it must be a max. And the other turning point, x is 1, f double dash 1 is 6 times 1 minus 4, that's 2. You're not bothered with that. Really what you're bothered about is it's bigger than 0, so it's a min. So we know that that value there, x is third, is a max, and x is 1 is a min. Again, going up, we see that that's exactly what's happened. Okay, so our technique's working. And then to put the values in, if x is a third, your value goes in there. F of x is x cubed minus 2x squared plus x minus 1, and that gives negative 0.0852. And then when x equals 1, excuse me, there we go, that's better, f of x becomes f of 1, so that turns out to be negative 1. So the function's got a local max at p 1/3 negative 0.0852, and a local min at q 1 negative 1. And again, makes complete sense, and you see here why we use the idea of local max and local min. In reality, what you would really do here is that at the next level up, you're always told to check the boundaries as well. So you basically just check these boundaries, that one there and that one there, to find out if it's the absolute, the global max and the global min. But anyway, that's not for this level, so just you concentrate on what we're doing at the moment. But hopefully that's going to be good for you. All right, so for that one there, that's the final answer. So hopefully, if you just work through it yourself, you should be getting that answer. Okay, so I'll leave that one with you to do on your own, and that's us at the end of the Max-Min series. Thank you very much.